Hello and welcome everybody. Thank you for joining us today for our Bringing the Power of Python to Robocorp's Gen 2 RPA webinar. My name is Tim and I'm a technical account manager at Robocorp, and I'm joined by two of my colleagues today, Blake and Eric. They will be helping to answer any questions that come through in chat and jumping in during Q&A. For our participants on the call today, we have everyone muted. If you have any questions, please put them in the chat or the Q&A section, and we will try to get to them as we go or during our Q&A portion. So before we get into the main topic of today's webinar, I want to spend a few minutes walking you through Robocorp's RPA solution. Robocorp was founded in 2019 and is built on the Robot Framework open source project. Robocorp is Python-based and open source as well, and has a consumption-based pricing model which allows you to get started, test, and prove value with a bot for little to no upfront cost. Like many of you already know, businesses have been using Python for RPA, scripting, or to automate segments of processes for the last several years. For many businesses, investing in a new tool can be expensive, time-consuming, and the ROI unclear. With Robocorp's RPA solution, because it is Python native, there's minimal uplift and no porting to get your current Python bots up and running. We build and maintain first-party libraries as well to support your automation, and these libraries are called RPA framework libraries. We are a fully extensible RPA solution with Python libraries, which really just means that you can add your own libraries or use third-party libraries, which is what our webinar today will be covering. Robocorp also created RCC as an open source project, and we use this technology to isolate our runtime environments from the local environment. And this can be really helpful when you're working on multiple projects that may have dependencies that are in conflict, or you need to install multiple versions of the same package. Now, everything I just mentioned is part of the Robocorp Automation stack. This is the tooling and the technology here that you're seeing. Now, in addition to the Robocorp Automation stack, we also currently support two IDEs. Automation Studio, which is our low-code drag-and-drop IDE. It's currently in a limited beta release and will be in open beta later this summer, as well as VS Code, which is our developer-focused and feature-rich IDE. And we also offer you a variety of ways to run your bots. You can run on our infrastructure, Robocorp Cloud, which is sometimes called Robocorp Control Room, and there's no additional costs using our infrastructure, or on your own infrastructure, or in your own self-hosted cloud. Now, before we talk about the nuts and bolts of getting your Python bot into Robocorp's RPA solution, we need to understand how RCC works and how it's configured. So there are a few parts to RCC that you'll need to understand, whether it's for a Python bot or a robot framework bot. So the first is the conda.yaml file. And I've got a couple of examples up here on screen of a conda.yaml and a robot.yaml. So the conda.yaml is where your project and the dependencies of your project are set. So like I mentioned earlier, RCC separates your runtime environment from your local environment. And this conda.yaml is what tells RCC what should be in that runtime environment. So this is where you set those things. And you can see that we support both conda.forge as well as pip. The next file I want to talk about is the robot.yaml file. And this is where you tell RCC how to run your robot, what's in path, and where to store artifacts. The nice thing about both of these files is that they're both basic text files. They're YAML files. And so you can edit them with something like a Vim or from inside of VS Code. Now, RCC can be run from both the command line as well as from VS Code. Now, the command line tooling can do all of the same actions that we're going to do later today. So if you prefer to do something like a Linux machine, you can also run RCC from there. Now, if you only take one thing away from today regarding RCC, let it be this. RCC isolates your runtime environments from your local environment. It does this by creating unique virtual environments, up to 10 of them, where each one matches a unique conda YAML. Now, this helps to reduce the overhead on your system if two or more projects have the same dependencies, i.e. the exact same conda.yaml file. RCC can also do things like zipping up your robot if you wanted to pass that project file over to someone else who's also using Robot Framework, and if you weren't using something like GitHub or some kind of source repository. Now, more on RCC can be found on Robocorp's doc pages under RCC. So for today's webinar, let's suppose that we have the following business process. Now, this particular flow represents a general business process where you get a daily file from one part of your business. You need to extract some data from it. You go to a website to retrieve additional data or capture a screenshot, and then you need to upload that to something like a CRM system such as Salesforce. And finally, maybe the last part of that process is you need to alert your team members that that CRM system has been updated and which case has been updated. And you might do that through something like Teams. So the process for getting your bot into Robocorp should be straightforward. And at a high level, you create a new Robocorp RPA bot using the Python template. You need to update your conda.yaml and robot.yaml files. And then you need to move your Python files into the project folder. So what you see on screen now is the Python bot that executes the process we just saw. And this is the bot that we're going to be migrating over to the Robocorp RPA solution today. So I'm going to assume that for this, you already have VS Code and the necessary extensions installed. If for any reason you don't, you need to walk through on that. We have a great YouTube channel that has some discussions on that. And we also have our docs pages, which will walk you through how to install those. So I'm going to do all of this with you live today. So to get started, we need to create a new folder for the new robot workspace. And I have already done that. And I've opened that up here in VS Code already. So you can see my folder business process example. So from here, we need to go ahead and create our Python template. So we can do that using, I'm on a Mac today, so Command-Shift-P, or if you're on Windows, Control-Shift-P. You can type in create, and one of the options is going to be this Robocorp create robot. So we'll go ahead and do that. Now this is going to kick off RCC, and it's going to bring up a few questions here. I'm going to choose a basic Python template for the purposes of today, and I'm going to use the workspace folder. So when you do that, it will go ahead and create all of the necessary files and structure in order for you to be able to create this bot. All right, so now that we have the Python project template set up, we need to go ahead and bring our files into the environment. So for this one, I'm going to go ahead and bring in the file that I had created earlier. And I'm going to go ahead and get rid of this default tasks.py. All right, so now that we have this Python file in, the next thing we need to do is go ahead and set up our runtime environment. And remember, we had talked about the runtime environment being separated from the local environment. And now what I need to bring into my runtime environment are my dependencies. And if I look here at the top of my Python file, I have all these imports. And some of these are native to Python, so you don't need to worry about bringing them in. But stuff like Boto3, OpenPyXL, PyMS Teams, and Selenium do need to be brought in. Simple Salesforce as well. You can see that here. So if I go to my conda.yaml, I can go ahead and bring these in. And now all of these are pip files, so I'm going to keep them under the pip section. I'm not bringing these in from Conda Forge, so I'm going to leave these under this section. And the other thing that I'm going to point out here is you need to know the version of what you're using. So you'll notice here that I've got everything set up with a strict versioning. So for example, OpenPyXL, I'm using 3.0.9. And so we recommend that you always do this where you keep strict versioning, because if I ever pass this robot file or this conda YAML file to someone else to run this bot on or to test, then they will always pull in these exact same dependencies. So you won't get the problem of someone using OpenPyXL version 3 and someone using OpenPyXL version 4 and those bots operating differently. All right, so now that we have our conda.yaml and runtime environment set up, we can go ahead and look at our robot.yaml. And you'll notice when I jump out of my conda.yaml that it sets up, RCC runs and downloads and does what it needs to do to get that environment set up properly. So you'll see this here for the next few seconds while it works. So I won't get into all of the robot.yaml configuration settings, but you can configure a few things here like I talked about, like your output path and your artifacts, and even what environment variable file you're using. So in this case, I'm pointing to the conda.yaml file here. But for this purpose, all we need to do is look at our tasks section. And specifically, we need to update this tasks to main.py because that's the file that I'm using here. The other thing to note here is that under my tasks section, that this shell option here, there's a couple of different ways you can set up your tasks, but this shell option here is the same as if I were to go to my local terminal. And if I were to navigate to this folder and I were to type in Python main py, so this does the exact same thing. So the nice thing about RCC using these shell commands as well is that if I had an argument that I needed to pass to this particular file, or I needed to run something just before, You can execute shell commands within this as well, which makes it really, really efficient. So now that I've got my conda YAML, my robot.yaml set up, and I've got my main.py in, there's still one thing that I need to do with this. This bot was originally set up using environment variables, and that's pretty common with Python bots. So because we had talked earlier about RCC separating my runtime environment from my local environment, that means that my environment variables aren't that easy to access. So one of the really nice things about the Robocorp RPA solution is that your vault file is something that we build native into our product. It's no additional cost, and you can store all of your secrets there. And so you can access them with this rpa.robocorp.vault. So I'm going to go ahead and update this now to get rid of my environment variables. And I'm going to go ahead and change everything over to be set up for my vault file. So that'll take just a second. All right, so let me go ahead and save that. Now that everything has been set up, let's go ahead and run it and see what happens. Now there's two ways I can run this bot now. I can go back to my command palette, just like I did earlier with Command-Shift-P, and I can click on the Robocorp run bot. The other way I'm going to go ahead and do this for you now is that I'm going to go ahead and go to my mark the monkey icon down here. And I'm going to go ahead and execute it through this extension. Now you'll notice, I want to point this out real quick, is that you'll notice when I'm under here, it's got my, my bot name, and then it's got this run Python. And if I jump to my robot.yaml, you'll notice that my task name here is run Python. So these line up. And so when I execute this, when I say run here, it's just going to basically copy and paste this in. It's going to run this directly in my shell, if you will. And it's going to execute it in this way. So this is how you can pass in arguments and other things that I was talking about earlier. So let's go ahead and run this now. And let's go ahead and see what happens. So if this is successful here in a minute, so it's going to go to AWS, it's going to grab a file, it's going to pull it down, it's going to extract some data elements from it. And then it's going to pop up this Chrome file. So far it looks good. It's typing in a couple of addresses that it extracted from Salesforce using that Excel file. And it's taking screenshots of each of these, because that screenshot is what I want to upload back to my CRM system. So that'll take just a second here to complete. And now that Chrome has gone away, it is now accessing Salesforce via API. It's now uploading that information to Salesforce. And then it's going to send a message to my Teams channel to let people know that that Salesforce process has been updated and it's ready to go. Awesome. So we got an OK here. So this tells me that everything went exactly as expected. So pretty nice. So you can see that all that we did here was we updated a conda.yaml, we updated a robot.yaml, and we brought in our Python code that was already written. And in this case, we updated some environment variables to use Vault. So getting started with an already written Python script inside of Robocorp's RPA solution really takes about 15 minutes. Now, let's assume that you've been coding in Python for a while, and maybe you want to leverage some of Robocorp's orchestration and infrastructure, but maybe you don't want to learn Robot Framework right now. Well, you have a couple of options. You can create a new Python bot like we did earlier, and you can just start coding directly in Python. If you decide later on that you want to leverage the human readable Robot Framework syntax, you can always pick it up as you go. Or, and I'll demonstrate this now, you can also do a hybrid approach. So for this portion, I've already written the Robot Framework for this bot. And in order to get started on a Robot Framework bot, you would do exactly what we did earlier. You would use the command palette. You would click on Create Robot. And instead of choosing the Python bot, you would choose a standard robot template. And so this code that you're looking at now in Robot Framework is for the exact same business process and the exact same bot that we had in Python that we just ran. And so if you look here at the task section or the test cases, you'll notice that this is telling you what the bot is doing. We're going to authenticate to S3, we're going to authenticate to Salesforce, and then we're going to do some other actions here. Now, the only thing that I have not done with this bot right now is Teams. I don't have anything sending that message on this bot to my Teams channel to let everyone know that Salesforce has been updated. So let's go ahead and assume that someone on my team has already written a Python section of a bot, right? So let's just assume for now that my colleague Blake has already written that section for another process and that I want to leverage that. So I can leverage that in a couple of different ways. I can bring in that Python file into my root directory and I can start using it directly. Or if I was using something like GitHub, I could also use a subtree, and I could take that from the GitHub repository, my common location, and I could bring it into my folder via subtrees if I was using something like GitHub. So for now, let me go ahead and do this a more local way and just bring this into my root directory. So I've just brought in my teams.py file that Blake has already written for me, and I'm going to go ahead and leverage that. So while we're here, while we're looking at this file, let's go ahead and talk about a couple of things that you can do with Robocorp's RPA solution and Python files. So you can see that I've included in my Python file the rpa.robocorp.vault import. And so because Robocorp is Python native, it means that you can bring our files in to your projects, to any of your Python projects, right? Whether it's a pure Python or whether it's a robot framework Python hybrid. So a lot of things that we've already built out, you can leverage and you don't have to recreate. So this is a really nice feature. You can see that I'm using here on line 25, I'm using this logger to send a message to my log file, which happens to be an HTML file. So very readable as well. So let's go ahead and jump over to the log file now and just show you what some of that logging looks like. So this is all native logging that comes directly with Robot Framework. If you're using the Python solution purely, then you won't get this native logging capability, but you can add it in there with the logger that we've just shown. And you'll notice here, and this is a prior run, you'll notice here on this line that this is the message that's coming in from my Python file. So I've got my message here, and I've added some case numbers, and I've added a link here so that someone can just click directly on it if they wanted to. And this is what's being sent to my Teams channel. So the other thing that I'll talk about in here, and the other thing to mention with logging is that we also respect the default Python logger and logging levels. So any library that you use that includes logging already will automatically be added to this Robocorp's logging file. So you don't have to do anything special. If you're already using logging in Python and you're running it through Robocorp, it will automatically add to this log file. So a really nice feature there. All right, and finally, the last thing that I want to address here is that for the Python library files, you must name the file, whatever this .python file's name, so teamsmessages.py. You also have to name the class the same, dropping the py. So Teams Messages is the class name, and Teams Messages is the Python file name. So just be aware that those need to match. Now, everything that I'm importing right now is pretty much native to Robot Framework. So I don't need to really worry about these imports. But I am importing this additional open source library, PYMS Teams, and I am bringing that into this particular file. So it is something that I'm going to need to go ahead and bring into my conda.yaml file. So I can go ahead and do that now. And this again is a pip file. So I'm going to go ahead and bring that into my conda.yaml for RCC to recognize. And then the other thing that I'm going to need to do is I'm also going to need to add this py file as a library. So in my Robot Framework file, I can type in library, and I can tab over because Robot Framework uses a tab to delineate arguments. And I can go ahead and type in Teams, and you can see that IntelliSense recognizes what I'm trying to do, and it recognizes this file, so I can go ahead and do that. So let me save that. And then lastly, what I'm going to need to do is I'm going to need to include what I'm doing here into my current robot. So you'll notice that the def here is send message to SFDC messages channel. And it's got one argument, which is the message here coming in as a string. So if you'll notice here how this looks, you'll notice it's all lowercase, underscores. And if I jump over to my tasks.robot, then I know I need this particular argument to be in line 68. So I can start using that def as a direct keyword. So if I start typing in send message, and you'll notice IntelliSense can give me an option. I can send a message using the AWS library, but this is the one I want right here. And you'll notice that IntelliSense picks up the library that I imported and is allowing me to bring it in. And it already knows that there's one argument. So the nice thing about these defs that we're creating in our Python libraries is that Robot Framework and the Robocorp RPA solution knows how to convert that into a human readable syntax. So you don't have to do anything special to get it to work right out of the box. And so in this case, I want to go ahead and pass my argument of Teams message, and that should complete my file for me. So another thing that I want to highlight before we run this and test it is that you can, if you're doing a hybrid, for example, you're doing a robot framework, but you need to use Python. And let's assume that in this case, maybe you have some Python that really isn't enough to put into a library. You don't want to build an entire library for it. Maybe it's a single line, or maybe it's just a couple of lines. So you'll notice here on lines 105 and 106 that I have an evaluate keyword here. And after that evaluate keyword is Python syntax. So the nice thing about us being Python native is that you can use Python directly in robot framework projects without having to do anything special. Put in the evaluate keyword and put in your Python. Because sometimes there's just things that are easier to do directly in Python, or you're already familiar with it. Again, you don't want to create an entire library. So a really nice feature here as well that you can do. So if we were now to run this, we would get the exact same result as our Python bot. So to wrap up this portion of our webinar, we have seen how we can take an existing Python bot, run it in Robocorp's RPA solution, as well as adding a Python library into a robot framework project. So that concludes the lecture portion of today's webcast, and we will now open it up to Q&A.
So Tim, we had one good question out there so far. I can jump in. I kind of answered it, but I just want to expand on this a little bit. The question was, what is the difference between running robot on Visual Studio using run robot and, as you have shown in the video, using the monkey symbol? So there's a lot of ways to run code in Visual Studio Code, obviously. Visual Studio Code's built-in launch.json allows you to configure how it would be ran, and then you have to configure it. You have to define how exactly Visual Studio Code is going to run, what it's going to run, et cetera, et cetera. So what the monkey symbol, as we like to call it, mark the monkey, that icon is where our extension lives. And inside there, you have multiple ways to actually run the code. When you hover on the left hand, actually, Tim, if you have it open, you might be able to show this while I explain it. But there's a play button, the debug button. So you got the debug button, you've got the play button, and then you can also use that command palette again to run the robot or debug the robot. And then what happens there is that when that launches it that way, our extension does all the launch JSON work, attaches the debugger for you, and then executes the robot in the RCC environment you've defined. If you run it other ways, like if you just type, like Python task.py or something, that will simply run the Python in your local environment instead of your RCC environment. So it won't do all that cool stuff we talked about with the environments. If you do want to run commands in the robot environment, sometimes to play with it, see what it does, exercise something, you can drop into the environment. There's an extra button there in the extension, or you can also use the command palette to open up a terminal. I hope that's a complete answer to that question, and why I always recommend using the robot extension to launch and debug your robot.
Yeah, excellent. Thank you. Any other questions that we have right now? So I'll go ahead and put the slide up again one more time just to kind of reiterate. So if you already have your Python bot created, you already have some RPA that you're doing or some scripting, then in order to get that into the Robocorp RPA solution, it's really as simple as getting your VS Code installed in your two extensions, creating a Python template, adding your Python bot into that workspace folder, and then update your conda.yaml for whatever your imports are, and then update your robot.yaml to point to that main Python file to make sure that you're executing the right file. So a really simple process. And you can see that we did it here within about 10 or 15 minutes today for something that was already written.
And actually, I'll jump on that, and we have another question after this. I'll say, but I thought about this. If you already have an existing Python file, you can drop your dependencies in like that and just run with it, and it should usually work. There's a very few edge cases where if you have dependencies that we also define in our RPA framework, that they might sort of have different version numbers and they might sort of conflict with each other. So in those rare cases, you might need to play with your dependencies, remove some that already exist, stuff like that. So it's not quite just a drag and drop, but those are hopefully more rare. Just FYI, I just had that today, so I just wanted to throw that out there as a new potential thing. So, all right, so another question here. Would there be any benefit of migrating an already existing Python bot to RC, I assume Robocorp? Yeah, definitely. To take advantage of the orchestration, really. Our work item parallelization is kind of what made me fall in love with it when I was a customer before. And I loved being able to just give my robot a arbitrary JSON payload of whatever it is. As long as it's serializable, you can pass it through the control room to your robot. And then it takes care of all the the parallelization for you through our infrastructure and stuff like that. So I think that's the biggest benefit. And like Tim showed you, you can get an existing PyBot in very quickly. If there's multiple robots open in VS Code in a workspace, for example, when I change between them, there is a dialog asking to clear the cache. Is it normal or if there's something wrong with the setup? So I recently had an issue similar to this where somebody was using one folder with a whole lot of robots in it. So they'd have like one folder and then like 10 more folders, and each one of those folders was its own robot. And then they would open the parent folder in VS Code. So VS Code had like multiple folders and multiple robots, multiple robot.yamls, multiple conda.yamls, and all those different folders. I would recommend, okay, yep, they did. Okay, so I would recommend against that. So the kind of the best practice is one repo, one robot, one folder, one robot. Open that folder in VS Code that has the one robot.yaml, the one conda.yaml, and then the code for that specific robot. That will also match the way Control Room expects to see robots, because when you load up a repo in Control Room, it's going to look for the one robot.yaml, and then it's going to give you the options from that one robot.yaml. If you've got multiple, I haven't actually tried to do that in a long time since I first started doing it, so I recommend against that. It's kind of one repo, one robot, one for one sort of thing, and it looks like that was the question. So got it. Don't see anything else right now.
All right, excellent. Yeah, great questions coming in. Thank you so much.
Through the documentation, we can find all the libraries available. Does a Pi overview of solid solutions exist as well? Well, our documentation is going to focus on the libraries we've created to help assist with the RPA actions. A lot of what we've done with the keywords, because you have to abstract Python to robot framework for robot framework developers, is that the libraries do a lot of work for you, especially all that logging and stuff. And it thinks through a lot of the common issues you might face when trying to implement a more low-level Python library. So it can help out a lot. But as far as pure Python, I think you would look at the documentation for those Python libraries. Take the Teams message solution. Is there more out there? That Teams message solution, okay, that's what Tim put together. So Tim, how did you do that Teams message solution?
Yeah, so the really nice thing about the Python, the open source solution that we have, and the fact that we're fully extensible is I knew the problem I wanted to solve. I wanted to be able to send a message, and originally I wanted to do it Slack, and then I decided to change over to Teams. But you can do both Slack or Teams. And so I just went into Google, typed in something like Python library for Teams, looked through a couple of people's documentation and code, found the one I liked, which was this PYMS Teams, and then just leveraged their solution, right? Looked at their documentation. And so I coded it up that way, imported them, and then created my own keyword for exactly what I needed to do based on their solution and their keywords. So really that was all there was to it. So again, it's really nice we have an open source and extensible solution. And so any Python library out there that's open source, you can tag on to us, right? So that's where I did it.
That's my same process. Look online for a solution similar to what I've already done and refactor it to make it work for mine.
Yeah, and I think the other thing that I'll probably mention as well is that, we are open source. So if anyone has a solution, they're like, hey, I've always got this problem. I know other people have this problem. If you want to create a library or you want to create something and provide it to the community, right? We have Portal that you can do that. You can create a sample bot and put that up on our Portal page. You can also contribute to our open source. If you wanted to add a library, right, you can look at that and look at how we do that and contribute to the community that way. So really good, really great things we can do there as well.
Yeah, in fact, team, I think Mika is volunteering you for that, for Teams.
I think so. Yeah, we can definitely get that out there. And all of these, by the way, all the code that I went through today, I do have posted publicly on my own GitHub repository. So if anyone wants to look at the code today, I'm sure we can figure out a way to get those out to everybody. We'll figure out a way we'll throw it in Slack or something, or the dev channel. I'm not sure, but we do have that. You can look at that code, you can play with it, you can test it and look at it that way as well.
Okay, we have another question. When we migrate Python bots to Robocorp, can we use our infrastructure, be it virtual machines, to run the robot? Would it use runtime similar to when we use the cloud offering from Robocorp?
Yeah, great question. So yes, you can use your own infrastructure. You can use your own virtual machines. And a lot of times, whether it's a Python bot or a Windows bot, well, Windows not being a language, but whether you're running that Python headless or whether you're running like a Windows environment for an application there, there are times where you have to run something locally. You have to run it inside your own kind of infrastructure. And so, yes, you can do that. And so if you were to put that code in Control Room on our cloud, The only time that you're being charged for is when that bot executes. So for example, it's that orchestration time. So if you have, let's say, 3 steps in a bot, first step is going to run on our infrastructure and it's going to go out, it's going to grab something, it's going to download a couple of things. And then the second step is on your infrastructure. And that infrastructure is maybe there because you have to have a local executable or something. So that time that it's coming down and working, there is a little bit of a charge for that because you are still using us for orchestration and we need to know when you start and when you end. And then when you go back up to cloud, you use our infrastructure, all of that time there is a charge for, but there is no cost for using our infrastructure versus your own. So, and if there are questions on costs and things like that, you can always talk to our sales team and they can work with you on a solution that works for you as well.
Could you suggest any solution to structure the project to make sure it is maintainable and scalable?
Yeah, I mean, I think that's going to depend a little bit on your project itself. But as far as maintaining, maintainability is from my experience has generally been by making sure your functions are reusable, making sure they're simple, right? If you try to put 12 or 13 different steps into one function, into one def, for example, it can start to get unruly. As soon as you need to change one thing, everything else is impacted. So the more that you can kind of keep your defs to kind of singular things, that can be very helpful. And as far as scalable goes, I think there's a couple of things I'll touch on here, and hopefully I answer the question. But when it comes to scalability, depending on the size of the problem, so we've had a couple of clients whose scalability is because they have, let's say, 10,000 rows of an Excel file that they need to process basically simultaneously or very, very close to simultaneously. So for scalability for them, that means that they have one portion of the bot that's going to extract each of those rows. It's going to create work items, which is an advanced concept that we have here. We didn't get into this today, but we have a work items concept. You can check it out on our docs pages. And then from there, they take each of those work items and they scale up on our infrastructure. So they've actually taken each of those 10,000 rows and they spool up, I think it was 20 or 30 different parallel bots, all for the exact same bot, or you don't have to code 20, 30 bots, right? It scales up from one bot to 30. And they're able to run 30 of those lines at a single time. And they're able to get through the source a lot quicker. So for them, that's scalable. So it really kind of depends, I think, what your definition of scalability is. But if you're talking purely about kind of code writing, it's, think about the kind of long-term and the maintenance of it. Hosting something in GitHub, for example, would be more scalable long-term than doing something purely in local dev. So hopefully that answered your question.
I have an off-topic question relating to open source projects. See here, Automagica was a promising Python RPA platform that disappeared from GitHub. Wexflow, really nice. I'm trying to get to the question. I can only assume that both projects were bought. Can we have an assurance that the same won't happen to Robocorp? So basically the question is, will our open source stuff stay open source forever is the question.
We are based on the Robot Framework. Robot Framework is an open source project that is not owned by us, but we are a major contributor to it. Unless we create, and typically the ones that we create is we upload back to the Robot Framework to contribute back to the community and keep that moving forward. From that standpoint, I would say yes, robot libraries are always going to be out there because it's the part of the open source org. And even if we were to get bought out by another company, we don't own that robotframework.org.
Next one. So is there a template for projects similar to state machines? One example would be Robot Framework from UiPath. I'm not sure about other panelists, but I didn't know what a state machine off the top of my head was. So I Googled that real quick, found the answer, I think. So I think I can answer it. I've not been doing programming my entire career yet, so I'm going to try to catch up real quick. As far as I understand it, state machines is sort of a computational method where you've got one state and it stays that way until you have an input and it changes, it transitions to a different state. There's only so many states it can be in. So there's a couple of ways you can kind of accomplish that through the work item parallelization system, which we didn't cover in the webinar, which again, where you have arbitrary JSON payloads, you define the keys in the payload and they can include files, and those can pass from step to step. You can also use other libraries to pass the same payloads from process to process. So you're able to build logic branches through our control room. So you're able to define a state, for example, perhaps in a work item. That work item has a state, a robot processes it, the state changes based on the process, and then it goes back up as another work item till the next robot processes it or doesn't. If it just sits there, it becomes whatever you need it to do. Then that's just a single work item in the control room. So I think that can kind of accomplish what you need. But as far as if there's a template for it, we do have a consumer producer template where you kind of have two different pieces of the bot. One reads that Excel file with 1,000 lines and very quickly creates 1,000 work items, essentially, that the next step would then actually consume those items. So that's where you get that parallelization from. And so you could build other ways, you can think of other ways to do it. And then of course, if there's features that are missing from that system, if what I just described doesn't quite meet your need from what you're talking about a state machine, let's talk and see what we can do to improve the offering, because new features from our community is what we thrive on. Hopefully that helps.
Yeah, and I saw another question come in here talking about the current workforce setup does not allow for routing of work items between different steps depending on some conditions. So I'd say that's probably a great question to jump into Slack and get some of our engineers. I'd also be curious what those specific conditions are. I'll quickly touch on work items here, high level. So a work item is just a package of data that you can basically send to Robocorp or send to our kind of parallel solution, and you can kind of operate them and scaling up, scaling down, things like that. But that work item itself is passed between steps if there's a workforce condition flag basically that you turn on between steps. For example, if you don't turn on those work item flags, it cannot pass between steps. So there are certain flags you've got to turn on, but that's probably a question that's better for us to answer probably over Slack with a little bit more detail, because there could be a couple of reasons why that may not be happening.
Yeah, and I can add a tiny bit there too, because if you're just simply talking about if-then conditional branching of steps, like being able to define that sort of in the control room, so you have maybe 5 steps, but 2 of them go sort of different directions. Yeah, that was a feature I wanted too when I was a customer, and I do know it's on the roadmap. I just don't know where it falls, but it is on the roadmap. I know that they are interested to get something like that.
All right, excellent. All right, it doesn't look like there's any other questions coming in. So I guess we'll go ahead and wrap up this webinar. So thank you so much, everyone, for joining us. We really appreciate it. The last thing that I will leave you with is this takeaway slide, a couple of great resources that we have. And you can, again, check us out on Slack, look at our docs pages, and Portal has some great examples. So thank you so much for joining us today, and good luck automating the boring stuff.